public discussion on climate change is bedeviled by a lack of context. And you've often heard independent scientists criticised, and in fact Professor Courtier referred to this, as not being real climate scientists, whatever a real climate scientist might be. Now, the people that use that terminology mean you're not a meteorologist or an atmospheric physicist or a computer modeler. In my view, that group constitutes about 20 or 30% of climate science expertise. In their view, it constitutes 100%. You will see during my talk where I think the balance of the context lies, and it lies in many other disciplines, and one of the very most important is earth sciences. My talk has two parts then. The first part is about context, and it's not particularly coherent in the sense that every slide follows from the previous one logically. Rather, it's a series of spot examples that I will give you to make you think about what is the context of this 0.6 degrees of gentle warming that we had in the late 20th century. Because we probably did have, well, if not 0.6, that might have some urban heat island effect in it, but certainly we had a few tenths of a degree of warming in the 20th century, and I want you to think about that in context. Then the second part of the talk I feel very uneasy about because I'm a scientist. And unfortunately, I'm going to talk about policy. And I feel, firstly, I don't particularly have expertise there, but secondly, one loses one's scientific objectivity, of course, as soon as one starts giving advice on policy matters. And that is one of the reasons why some of the major scientific societies in this world have lost their way, because they have started to give advice to government on policy and they have accepted funding to give that advice. Now, Lord Monckton, who will be known to all of you, regarding the fact that dangerous global warming caused by carbon dioxide emissions not being a problem, because there's no empirical evidence for it, and many people in this room would probably agree with that. That's not to say carbon dioxide isn't a greenhouse gas, but empirically there's no evidence for a dangerous rate of warming caused by our emissions, or indeed any warming that's measurable. So in that context, Lord Monckton says the important thing to do about a non-problem is have the courage to do nothing. Now, I agree with that, but I also live in a real world. And there are so many important people right through the political, public, commentariat and scientific community that have vested their reputations in this dangerous global warming that you cannot do nothing. That is not a realistic policy alternative. And the reason I'm going to talk about policy in the second half of the talk is because I want to offer you a realistic policy alternative. Okay, so context, first of all, in a geological sense. We have here a slide of the last 6 million years of Earth history, and the temperature curve in red is a marine seawater temperature curve from the Middle Pacific Ocean, collected from deep sea drilling cores. And we are today at 0 million years here, and this is today's temperature. The measurements on here are oxygen isotope ratios, which we've already heard about. That can be translated into a rough temperature scale between warm and cold here. That's about a 10-degree change in temperature at Vostok, at one of the ice cores. And what we see straight away, because the question we would ask in context is late 20th temperature change unusual? And the answer is very clear. If this is today's temperature, then for 3 million years back here in what geologists call the late Miocene and the Pliocene, the temperature was 2 to 3 degrees warmer than today. Yet every month in Der Spiegel, you hear about this dangerous warming of the late 20th century and how it's unparalleled in history. Well, yes, it is unparalleled in the last 150 piddling years that is all meteorologists have to study. But in terms of context, there is nothing unusual whatsoever about this temperature here. Furthermore, not only was, for 3 million years here, the temperature 2 to 3 degrees warmer, but right here in the last interglacial, the temperature was about 2 degrees warmer than today. And I don't have the time to show you the slides, but if you then say, aha, Bob, it's not the magnitude, it's the rate at which the warming is happening, the answer is no, it isn't. There's nothing unusual about the rate of late 20th century warming in here either, compared with earlier geological rates. So in context, is late 20th century temperature change unusual? The answer is no. That is not my opinion. There are literally thousands of geological data sets that confirm that finding. You will note also that the planet was populated at this time by the plants and animals that we still have around us today. And they are mostly pre-adapted to a temperature 2 to 3 degrees warmer than today. The idea there's going to be a biodiversity crisis if the temperature goes up a degree or two could only be something that occurs to an ignorant person. Now, Professor Cortolo has shown this slide, and it's actually derived from Richard Linson's testimony that he gave to Congress a few weeks ago. And again, I want to look at internal climate variability and multi-decadal oscillations, and note that these are the individual monthly observations that go into the Climate Research Unit's calculations. And we see straight away there's a lot of internal variability here, about a 4 degrees centigrade range of internal variability. We then go on to the average, which we've already looked at, and on the same scale, 0.24, 0.24, well, you can see the warming, but it's very small. And in the context of this range of variation, this doesn't look like anything that is terribly serious. But we never see it like this. We always see it like this. Plotted now, look at the scale, 0, 0.2, negative, 0.4, negative, 0.6, 0.2, positive. So the way in which the late 20th century rise is made to look alarming is by deliberately expanding the scale. This is graftsmanship. It's trickery. Here, we have a warming that took place between 1900 and 1940, and the warming in there is about 0.9 degrees Celsius. It's natural because it's prior to the post-World War, Second World War burst in carbon dioxide emissions. And here we have the late 20th century warming between about 1969 and today, and that's about 0.6 degrees. And this is supposed to be human, and that's supposed to be natural. But in context, this human so-called rise here is nothing unusual at all. It's the same slope as this, and it's in fact not as great in its magnitude as this. Now you can see here a multi-decadal cyclicity. And I'll come back to that. Richard Linson's second slide before the Congress was this one. It's his hometown of Boston, and it's the temperatures in March and April 2008. And what is plotted in the dark grey in here is the expected average high and low temperature for the day. And as you will see, it climbs very gently through the month, as you'd expect, because you're coming through into spring and later spring here. The blue bars are the temperatures that are actually measured. So on March the 30th in this year, it was 43 degrees or so was the high, and about 28 was the low. And that's a little bit below the expectation. Okay, and then the light grey in the background is the record lows and highs over the whole 100 years of record. So the variability of Boston temperature summed up by that, and the red line across the middle, the thickness of that line represents the range of the global mean temperature anomaly over the last century. It is very, very hard, looked at in context, to argue that that change is in any way dangerous, even were it to be known that it was human caused, which it isn't, of course, known. Well, Russian work from their major Petersburg Arctic and Research Center, so these are now not global figures, these are Arctic figures, demonstrates the multi-decadal oscillation very nicely. And this data set goes from 1900 to 2000, and it's then projected out to 2080. And when you fit this a curve through this, you will see that the prediction is that for the next couple of decades, Arctic air temperature is going to decrease, and the ice cover in the North Polar Ocean will increase. So those of you that have bought shares in shipping companies, expecting to make lots of money because they're all going to go via the Northwest Passage, I'd sell those shares as quick as I could if I were you. Now, the version of this curve was first plotted in here, and the prediction was made that this was what was going to happen next. So this has, in a sense, had one validation test, and it passed it. That's not to say that it's necessarily going to be right down here, but it's had one validation test. None of the IPCC general circulation models have passed any validation test, and all 21, I think it is, of them projected that warming would take place over this same period from 1990 through to 2010. So they have actually, insofar as they've had a validation test, failed it. There is more than one type of computer model, is the message to take out of that, and this is a statistical or empirical model, and the statistical or empirical models are actually much more accurate, as far as we can tell from the tests we've had, than are the GCMs. Okay, well that's the context, if you like, of diurnal and then multi-decadal change. Now the context of human influence. This is an Australian average of 25 regional and remote country stations from 1882 through to about 1992. And what you see is basically no change over that time, a slight cooling trend and a slight warming trend. If we now take the 6 capital cities of Australia, and we find that we've got a very marked warming trend starting in the 1950s and coming up here. Now, this is attributed, not just in Australia, but in lots of places, to urban heat island effect. So we build Berlin and we replace original trees and grass with concrete, macadam, steel, glass, and that traps the sun's rays during the day and re-radiates it overnight more than the vegetation did, and of course that creates this little local heat bubble. Now, together with other independent scientists, I'm often accused of denying that climate change occurs, which of course is nonsense. It occurs the whole time. I'm then told, well, I deny that humans have any effect on climate. That's nonsense too. We all know humans have an effect on climate. Here's the evidence. But it's local climate. So, locally, humans cause, or human activities cause warming. But equally, and this is Melbourne as it happens, and the heat island over Melbourne, here's the temperature in the surrounding countryside, and over the middle of the city it's as much as 8 degrees warmer. Not surprising, because the temperature gauges are surrounded today by high-rise buildings and motorways. Now, so locally we cause warming, but out in the countryside of Western Australia, we have these magnificent wheat fields over a belt about almost 1,000 kilometres long, and here's the native vegetation that has been cut down to create those wheat fields. And it's quite obvious that its albedo is much less. It's darker. So the sun's radiation coming in now is reflected more off the wheat fields than it was from the original dark vegetation, and locally that causes cooling. So of course humans have an effect on climate. Locally they cause warming, locally they cause cooling. Now even an Australian can work out that if you add up all those little warmings and coolings around the world, there's got to be a net global signal. Has to be. Nobody I know denies that. You wouldn't be a scientist